Hey guys, this is Aryan, and I have finally come back from a month of research on my latest project called Synhibit. I'm so pumped to share what I've been doing with you guys. So, Synhibit is a MATLAB based machine learning tool that's basically the first of its kind that can generate and predict whether a certain compound can prevent cancer before it happens. So, as you guys know, I've been focusing a lot recently on cancer research, and it's absolutely fascinating. And you might have also noticed that I've been working on a similar project before this called Pentra. What I did was I used machine learning to accelerate the drug development process for neurological drugs so that they could penetrate the blood brain barrier. Now, what I'm doing is taking a bit of a broader approach into cancer treatment. And actually, I saw that there was quite a big hole in what I was doing. I saw that instead of treating cancer, why not prevent it before it happens? And I saw that that's literally what no one has been doing for almost all of cancer's existence in the 2000 years that it's been going on. Isn't it pretty insane how we treat cancer like a completely different problem as to how we treat all the other diseases? Think about it, like the flu or the common cold. For both of those diseases, we have two different measures to stop people from getting the disease in the first place. We have a preventative measure and we have a curative measure. The preventative measure would be vaccines, and the curative one would be just medications. But for cancer, we only take one of those aspects and we completely neglect the other. And I saw that prevention is so much more valuable than a cure because that could save both sides, like the government and consumers, so much extra time, effort, and lost health and productivity in the process. Why not prevent cancer before it happens? That's not the question that most people were asking. So I decided, why not try tackling the problem in a little tiny way of my own as well? So I thought, what are the two things that I'm super passionate about so I can blend them to create a completely novel solution to this problem? So I was already researching cancer, and as you might have seen from my previous videos, I'm pretty obsessed with machine learning. So just a quick overview of machine learning for those of you who don't know what it is. It's a statistical method that allows computers to develop models that can fit data that humans can't even comprehend. And seeing the applications of how I could use machine learning in this field, it was basically just a perfect fit. So I started on my way to developing a model. But of course, I just couldn't get too hasty with building a model because it's kind of hard to build a model without any data. So, data is the king of artificial intelligence. That's what you need to develop any sort of model that can train a computer effectively. Since no one studied this field, basically, it was pretty hard to find that data set online. And usually that's the case with doing machine learning applications for new purposes. So, I did the next best thing. I created my own data set. The way I did this was I found a list of millions and millions of cancer inhibiting compounds. And these compounds were available freely on a website that I found called BOC Sciences, Best of Chemical Sciences. With all of these inhibitors that inhibited all these pathways, I had to manually create an Excel list, which did take a lot of effort, but I think the results were pretty worth it in the end. You'll see. With my list, I also had to add the negative class. So while we have inhibitors of the positive class that do in fact prevent cancer, we needed something for our model to compare to as a reference. We can't just be comparing with one class. That's how machine learning works. What I did in this case was, since we wouldn't know the cancerous properties of every single compound in existence, because of course research hasn't taken us that far yet, the only surefire method of getting a 100% accurate negative class was essentially gathering a list of carcinogens or cancer causing compounds, as we would know for sure that those would not, in fact, treat cancer. So, fast forward to when I've painstakingly gathered every single compound on the list and every single carcinogen on the list as well, and turn that into a spreadsheet. Now is where the fun can actually begin. My favorite part is training the model. Now, I know how to code models, but the thing is that I'm lazy. So I like to use two major platforms, especially for my applications that I broadcast out on YouTube, especially when I'm at a time crunch. Two platforms are Microsoft Azure and MATLAB, which I've used for this project. So the things that I really like about these platforms is that you don't have to use any code, at least on the end of the developer, and you still get that level of customization that you would have gotten if you just used cold hard Python or even JavaScript. So that's super great. So after inputting this data set into MATLAB Studio, it's basically a piece of cake from there. MATLAB automatically detected columns, headers, categories, everything. And all I had to do was train every single model on the list, and we were good to go. Moving on to when I've basically trained every model in MATLAB's pretty long list of models. I saw that one model significantly outperformed the rest, and that model was called a naive Bayes model. Now, I have a pretty good idea as to why this would have happened. My dataset was very scattered after plotting this dataset on almost every combination of variables possible. Naive Bayes was also really good at fitting very fine curves that could go around these points to classify them the best possible. And that's exactly what ended up happening. Alrighty, moving on to the results. Now, if training the model is like my favorite, results are going to be here. It's the thing that basically all of this hard work goes into to get that high accuracy. Now, let me tell you again that these metrics don't disappoint. So, after training the naive Bayes model, optimizing it, after everything is said and done, this model achieved an accuracy of 92.3%. That is absolutely insane considering the amazing applications that this model could have. Now, looking at this accuracy, of course, data set needs to be in large sample size, needs to be bigger, but all that aside, with this same accuracy, we now know that we can consistently and reliably gather, generate, and even sift through millions of compounds so we can now judge whether these compounds would be great for preventing cancer. That is just absolutely mind blowing, especially considering that this could be the basis of, let's say, a future cancer vaccine that you might be injected with. With results that are that great, I don't think I really want to stop. So I have a lot of things planned to really increase the significance of what just happened. In the pretty near future, so roughly the end of this month, I'm going to be working on what's probably the biggest web scraping project in the field of chemistry ever. This whole project is to try and find that one compound that could be the most promising in inhibiting a major cancer pathway. I think you guys would be really interested in that. So if you really are, then please feel free to subscribe, drop a like, and turn on your notifications so that you can be notified whenever a new video drops, which is not as often as I would like, but I'm going to try my best. If you guys want to know more about this project, feel free to contact me through my email, which I've provided in the description below. Check out this project, which I've also linked in the description, and just look forward to what's about to come because there's some big things coming, guys. That's basically it for now. See you later.